So to carry on with the fractionating, to carry on with the separation techniques, we have distillation and fractional distillation. Simple distillation, fractional distillation. Basically used when the substances are miscible, like salt in water is dissolved totally, or alcohol in water, or ink in water. And many of the perfumes, okay, large scale usage of these things are basically the perfumery. Different perfumes or extracts of the plants, they can be separated out based on their different boiling points. Or fractional distillation, the large scale use you might have heard about crude oil. The black gold is sucked out, leached out of the ground, the earth interior, and then it is supplied to an oil refinery where this crude oil is fractionally distilled to separate all the useful fractions like gas, like petrol, like diesel, like kerosene, and other things. So the large scale fractional distillation usage you will have your syllabus in organic chemistry and other places. But when we start with the experimental techniques, to get the basic idea, distillation is used when the substances are miscible into each other. When we say simple distillation, it means you need a distillation flask and a condenser. We call this condenser as Liebig condenser. Okay. Now, when you heat, the principle of the separation is different boiling points. Just like I said, a physical property you need to point out, which you can exploit. When you will heat, the substance whose boiling point is less, it will turn into gaseous vapors. So it will have the highest proportion right here. And when these gaseous vapors pass right from the air, you will find out that it enters into the condenser. And the condenser, when we call it as condenser, it means it cools. Okay, there is a continuous supply of cool water. It fills the condenser completely. That's why cool water in is at this place, and then water out. Water in lower and water out above. It means above like this. There's a pipe going down. So when you put it right here, if water in, then the condenser might not fill completely. To fill condenser completely, water in is at the low position. It is filled completely. So the gaseous vapors, when escape through the condenser takes away their heat, and they condense back again to what? The liquid. The receiver must be open to keep the air pressure normal, to prevent pressure developing up, and the receiver will receive what? The distillate, the liquid with lower boiling point. Okay. You can find out on the thermometer, like if it is alcohol and water, the temperature started to rise if it is at room temperature, and then at its boiling point it becomes constant. Suppose the boiling point of alcohol is 78 degrees Celsius, you will have a constant temperature line, and then the temperature start to rise again. If it is water, it should become constant at 100 again. But when state is changing, that extra heat is consumed in changing the state, and it is taken up by the state change molecules. Okay, they are turning into vapors, they are taking away, stealing away the heat. That's why it is hidden, it is not shown. Okay, it is latent heat. So simple distillation may not be that accurate, because the other substance, like if it is substance X, low boiling point going up, but the other substance Y has a lesser boiling point, but still it is evaporating, because evaporation is a continuous process at all the temperatures. Even in colder climate, there is a surface escape because of the kinetic energy exchange. So some of the vapors of the other substance also intervene, and they are cooled here and then they are poured here, and so it may not be that 100% accuracy, but it can separate largely up to much larger extent. If you want much more accuracy, you need to add an apparatus in between the Liebig condenser and the distillation flask, and that is called as what? Fractionating column. Fractionating, it will separate the fractions. And why it will separate? Based on the different boiling points. Remember, the substance whose boiling point is reached, suppose X, lower boiling, whole the apparatus will be heated up as its boiling point is. Okay, suppose 78, whole apparatus is heated to 78, and the vapors will definitely be fully energized. They are at their boiling point, no stopping. They passes through the condenser, cool down here, the water steal their heat, and they are lowered. But the substance whose boiling point are more than the substance X, okay, like the substance Y, they vaporize, as in the simple distillation I explained. But as these vapors passes through the fractionating column, they strike to the colder part, the glass beads. At 78, its boiling point may be 100 higher, so they lose their energy, and when they lose their energy they are falling back. So fractionating column ensures that separation is done based on their boiling point, and the substance whose boiling point is yet not reached is sent back. Fractionating column, in one word, send back the vapors, cool down the vapors of the substance which are boiling without their boiling point. They were evaporating. Fractionating column sends back the vapors of the high boiling substance back until their boiling point comes. Okay, so this adds in accuracy. You'll find out later in detailed fractional distillation that in crude oil separation the fractionating column is high tech based on selective condensation plates, and also fractional distillation is used largely to separate air fractions, like nitrogen gas is separated out and given out, sold to ammonia industry. Okay, and many where the nitrogen is used, liquid nitrogen, -196 used as cool and cooling. Oxygen supplied to hospitals and other places, oxyacetylene flame, from where it comes? You cool down the air, turn it into liquid air, and then you apply fractional distillation. So in air environment chapter, you will find out that fractional distillation of liquid air and crude oil separation in the organic chemistry. But distillation used to separate substances based on their different boiling points. Low boiling substance vaporizes, condenser do the job, cools down the vapors back, and they are collected right here. It is called distillate. Okay, low boiling substance changes to liquid first and it's collected there. It means first it is heated, evaporated and cooled. Here again evaporation is done, and the vapors of the substance whose boiling point has reached, they will manage to pass all the hindrances, obstacles. They go there, but the one whose boiling point is yet not reached is checked by the fractionating column. So more accuracy. Sometime at the larger scale, somebody may ask you how seawater is separated, because these are expensive techniques, because you need to supply constant heat, fuel. So seawater can be collected in large reservoirs, and then in between a membrane is placed, high-tech permeable membrane, semi-permeable membrane. Okay, semi-permeable membrane. So it will let the solvent to move, but it will prevent what? Solute soluble salts. Such a permeability it has. So we call that process as desalination, because it is a sort of reverse osmosis. That solvent is drawn back and solutes are kept behind. Okay, so large scale usage of desalination is obtaining pure water from seawater, because that is manageable. Once the installation of semi-permeable membrane, it will let the solvent to pass through, do the reverse osmosis, but solutes are stayed back. Desalination, large scale usage. Okay, but distillation and fractional distillation, they have their own uses.